In order to solve number 11, we're going to rewrite this in exponential form. So base 5. So 5 will always be the base. This will always be our answer. And our exponent will always be found on the opposite side. Now, if we're asked to solve for x, we need to eliminate this 5. So in order to do that, we're going to use logs because we have an exponent that's in, we have a variable in the exponent position. So I'm going to do log base 5 to both sides and bring down what already existed. On the right-hand side, I have log base 5 of 20. On the left-hand side, these will cancel out. In reality, they turn into a 1. They don't just disappear. And I get to bring down x plus 2 equals this quantity. And to isolate the x, I'm going to subtract 2 from both sides. So x equals log base 5 of 20, then subtract 2. Where is that answer? It is... Okay, now, we don't see that exact answer because what they did is they did change a base for us. Remember, if you plug this into your calculator and you have one of the older calculators, to do that you would type in log of 20 divided by log of 5, log of the back number divided by log of the base, and then you would subtract 2. Correct answer is D as in dog. Highlight if necessary, please. Then flip back at this time and find number 8. Okay, this is going to ask for us to do a lot of analyzing of two different types of graphs. I can see this is exponential, and it tells me specifically that this data relates to a quadratic function. Okay. Well, I already have a formula to plug in for this, but I don't have a formula to plug in for this one. Let's figure that out. Do second plus 712. Hit stats. Again, hit stat and hit enter. I'm going to put the x values into L1 and the n of x into L2. Okay, what do? Well, we know it's quadratic, so do me a favor, hit stat, calculate, go down until you see quadratic regression, and press enter twice. For mine, hopefully yours doesn't look like this, I just keep entering through. Do you have the same answer? What do I do with this? Let's write y equals, okay, the a coefficient is 2, so 2x squared plus 0x plus 4. So this equation is y equals, or n of x equals 2x squared plus 4. That's the equation. All right, we are going to graph these two equations, and then we're going to analyze the information. Go back to y equals, please. And I'm going to type in the first one. Now, to make sure that this 3 is not somehow mistaken as being an exponent, I'm going to put the 3 in front. So I'm going to do 3 plus 2 raised to the x. Just to illustrate, my fear is that it will look like this otherwise. 2 raised to the x plus 3. Can everybody see the difference? This 3 is not part of the exponent. And on the older calculators, unless you move it down, it could be an easy mistake to make. So I'm going to move this vertical shift in front. All right, now I'm going to put in the second equation, which is 2x squared plus 4. This is my first equation. This is my second equation, first and second. And let's graph them. I'm looking at the first equation right now, and I'm looking at the second equation next. Can everybody see the 2? So this equation comes in here. And it's looking something like this. And then this equation is looking like this. Okay? Here's my m of x, and here's my n of x. All right, let's look down below. Select all statements that are true for the 2 functions. Just so I don't move too fast, how many of you have the same picture of the 2 graphs on your calculator right now? Hands raised so I can see. Does anybody need a little more time to get those up? Okay, here's our first one. Are both functions decreasing between -3 to -1? Well, remember, decreasing means going down from left to right. Well, let's zoom in and see. Let's zoom in and see. Put your hand right now at -3 and put your hand at -1. It'd be this little picture. I'm going to help us out by actually just going in between those sections. -3 to -3 to -1. Let's look at the 2 graphs. Okay, that's the first graph of the exponential, and we can see it's slowly moving up. This is the second graph of the quadratic, and it's slowly moving down. So this statement says both functions are going down from -3 to -1. Is that true? Because in reality, what's this first one? It's actually slowly going up. Yes, the second function is going down, but not the first. So this is a false statement. I'm going to go back so you can see them. The second one says the x-intercepts of m of x is greater than the x-intercept of n of x. Well, does either one have an x-intercept? No, neither one has an x-intercept, so we get to cross it out. Remember, this is a horizontal asymptote right here at y equals 3. Okay, your third statement says that the values in this equation will always be greater than the values in this equation when x's are greater than 0. So let's go up to Windows, and let's change this from 0 to 10. So let's only focus from 0 to 10. Is it true that the values in the first equation, okay, now it's hard to tell which one is the first. Let's go and look through this again. This is your first equation, this is your second. It will graph this one and then this one. Okay, right there is your exponential. And there's your quadratic. Here's your exponential, m of x. Here's your quadratic, n of x. Okay, exponential, quadratic. Is it true that the y values in m of x are always greater than the y values in n of x? We'll do second table. This was the first equation I plugged in. It's my first equation. It's the exponential. So what I see in this table is this is m of x. Are these values where x is greater than 0? Are these values here always greater than these values? Is the m of x values always greater than the n of x? Yes or no? In fact, as I'm looking here, are any of them greater? Okay, we get to cross it out. Do they have the same y-intercept? Well, y-intercepts always occur when the x value is 0. So here's the y-intercept. Do they have the same y-intercept? Yes, they do. The m of x values are greater than the n of x values when x's are less than 0. So let's go backwards. Scoot down here so we can see. Are these values greater than these values when x's are less than 0? Is this value greater than this value? Okay, cross it out. And m and n are increasing when x is greater than 0. So right now I have greater than 0. Are they both increasing from left to right? And circle, please.